I will be discussing factoring based off of the GCF, and this video is going to be several parts to this series. So GCF stands for greatest common factor. And let's go over a couple of things so that when I'm speaking the language, you'll know what I'm referring to. Operations are your plus, minus, multiplication, division. So those are the signs that you will see that will separate what's known as terms. Your terms are before and after the operations. What I'm looking for when I'm factoring is the first thing I want to look for is whether or not those two terms, in this case, because this is a binomial means there's two terms, trinomial means three, so on and so forth. And what I'm looking for is what do they have in common? So if I'm looking at my first term, which is negative 5x, and then I'm looking at my second term, which is 5, I notice they both have a 5 in common. So that's the biggest number that they have in common. So I'm just going to go ahead and bring out a 5. Now, a rule that you should also note is your leading coefficient. That means the number that is in front of your highest exponent. So if I'm looking at my terms, the only exponent that I have is x to the first power. My second term doesn't have an x, so it doesn't exist. If I had something like x squared plus 2x, again, my leading coefficient is the number that's in front of my variable with the highest exponent. You don't see a number there, it's understood to be a 1. This case, there's a positive 1. But if there were a negative 1, then if this was something that was factorable, then I would want to factor out that negative sign. So that's what I'm going to do here for part A. I see that they both have 5 in common, but I also see that my leading coefficient has a negative sign. So I always want to factor that out as well. So what's left over, I'm going to put it in a set of parentheses. What I am really doing is just dividing both of these terms by what I just took out, which is the greatest common factor. So this is what I'm doing. So negative 5 divided by itself leaves me with x. Positive 5 divided by negative 5 leaves me with negative 1. I have just factored using the greatest common factor method for part A. Part B, I noticed that I don't have numbers in common, but I do have variables in common. So what you want to look for is the one that has the smallest number. And let me show you why. For the first term, it's n cubed. N cubed simply means I have 3 n's, right? And for the second term, I have n squared, which means I have 2 n's. So GCF, greatest common, how many of those variables do they have in common? They both have 2 in common. So the first one still has 1 left over. So what I circled was the greatest common factor. So what I'm going to do is just bring that out as n squared. Again, what I am literally doing, let me just bring this down some so I can have some space here. What I am literally doing is dividing each term by what I just said was the greatest common factor. What's left over will go inside of a set of parentheses. So the way this works is, as I demonstrated over to the right, if I took 2 of those n's out from the first term, I have 1 left over. And that's because if you just know the rules of exponents, n squared plus n to the first power is going to result back in that n to the third power. Because when you factor, that's all you're doing. You're just rewriting it in a different form. So now I'm going to bring down the next term. Negative 2 divided by 1 is negative 2. And then n squared divided by itself is simply 1. So negative 2 times 1 is negative 2. So that's going to be my final answer for this one. Again, you want to always double check it. N squared times n is n cubed. N squared times negative 2n is negative 2n squared. And again, that is what you started out. That's what you started out with originally before you start dividing anything out. So that is how you factor out the greatest common factor for binomials. Let's just say I have a trinomial, which means now I have 3 terms. 1, 2, 3. Remember, the terms are separated by the operations. In this case, I have a positive sign. There's multiple ways to do this, but let's go ahead and over to the side. What I'm going to do is just write out for each term, what do I see? I see for 12, if I just look at it, I'm trying to see what is the biggest number I can divide all three of those numbers by. So the 12, the 16, and the 20. Some of you automatically know immediately, but others of you need a little practice. So for number 12, the factors of 12 will be 1 times 12, 2 times 6, 3 times 4, and that's it. Then if I go to my second one for 16, I have 1 times 16. Most people forget the 1 times the number. Then you have 2 times 8, and then 4 times 4, and that's it for 16. Now, if I go to the last term of 20, I have 1 times 20, 2 times 10, and 4 times 5. So now I'm going to look at all of those factors, and I'm looking for each one for 12, for 16, and 20. What is the biggest number that they all have in common? Well, I can quickly see that it's 4. So I know I'm going to bring a 4 out. And what did I say? I'm literally dividing each of these terms by 4. Now I'm going to look at each of the terms, and I see that I also have a variable x. So for the first one, I just have 1x. For the second term, I have 2x's, sorry. And then for the third term, the one with 20, it says x to the 4th. So that's really 4x's, right? So how many x's do they all have in common? Whatever the smallest one is, that's what they all have in common. So they only have 1 x in common. So that's what I'm going to bring out. What I bring out is what I'm literally dividing everything by. After I bring out my GCF, I put a parentheses, and what is left over goes in that parentheses. So now just simplify. 12 divided by 4 is 3. X divided by x is simply 1, so it goes away. I bring down this sign, plus. 16 divided by 4 is 4. X squared divided by x is, your rules tell you to subtract. So 2 minus 1 is just going to leave me with 1x. And I could also go over to the other side where I demonstrated. This was my first term, and this was my second term. What was left over was just 1x. And then for the next one, 20 divided by 4 is 5. And x to the 4th divided by x to the 1st, I just subtract the exponents. 4 minus 1 is 3. So I have x to the 3rd. Or again, I could go over here and just see how many are left over after I circled what's in common. Another way you can do this problem, which is a way that I don't necessarily recommend, is to use your prime number strategy, which means that you're just going to keep simplifying until you get down to prime numbers. A prime number is a number whose factors are only 1 in itself. So if I'm using 12x plus 16x squared plus 20x, the same problem, and I wanted to use that, the prime number strategy, I'm going to just find some factors of 12. I'm going to say 4 and 3. You could say 6 and 2. You just keep going until you get down to prime numbers. Well, 4 can be factored again, 2 times 2. I can't do anything with 3. So, and then that x, I'm going to bring that down. So everything I'm bringing down, I'm multiplying, right? So now I go to 16. You could do 8 times 2, but I'm going to do 4 times 4. 4 times 4 can be further simplified as to 2 times 2, another 2 times 2. And then I have x squared, which is really 2x's. See what I mean? I personally wouldn't use this method, but for those people that want to see it. So 4 times 5 is 2 times 2. Can't do anything with that 5. This x to the 4th is really 4x's. So x times x times x times x. So now what you're doing is you're trying to go to each one of the branches of, each term, let's just say that, and see what do they all have in common. And they all have to have it in common in order for it to be a greatest common factor. So for for the first one, I see that they have a pair of 2's. The 16 also has a pair of 2's. And then the 20 has a pair of 2's. Now, don't try to grab this one because that would mean that the other 2 would also have to have another set of 2's, and they don't. So now going back to the 12x, I see that that one has an x, the second one has an X, and the third one has an X. What's left over will be my answer. So what I highlighted is my greatest common factor. 2 times 2 is going to be 4, and then I have an X. What's left over is 3 in the first term. And then for the second one, the highlighted part is already taken care of. I don't have to look at that anymore. All of that's gone. What's left over is the sign that's in between the terms. And then I just multiply that 2 times 2, which is 4, and I still have an X. I go to the next one, I bring that sign down that's in between the terms, which is a plus. What's left over is 5, and then I have 3 X's, which is X cubed. And again, that's the same answer that I got a few minutes ago. I personally don't like that method, but again, some people like to use that method. So there you go. And then my final example for today is going to be when it looks like this. So I'm doing the same thing. I want to go ahead and try to figure out what is my greatest common factor. And it's in standard form, meaning that my largest exponent is first and then it's counting down. What this means is my leading coefficient has a sign of negative. So I'm going to remember to factor that out when I'm factoring my greatest common factor out. Everything else, what I want to do is just try to figure out the factor. So for 27, I'm just going to use 27 versus negative 27. I have 1 times 27, and then 2 times nothing, 3 times 9, and those are my factors for 27. For 15, I have 1 times 15. I have 3 times 5. Yep, that's it. And then I already did the 27, so we'll just keep up with that one. And then for 9, I have 1 times 9, and then 3 times 3. So those are my factors. Again, we're looking for the GCF. G is important because guess what? They have 1 in common, right? But that's not the largest number that they have in common. The largest number they all have in common is 3. See, this one doesn't have a 9, so we can't include 9 and say 9 is the greatest common factor. Now, I have to remember again, my leading coefficient has that negative, so that's going to come out as well. So so far, I know I have a negative and a 3 that I'm going to take out, but I also have a variable. So I want to look and make sure that each term does in fact have a variable, and it does. So based off of what I told you a few minutes ago, you always want to look for the smallest exponent, because of course that's going to be your greatest common factor that they have in common. Again, visually, if you wanted to see it, the first one is n to the 5th, which means there's 5 n's, then there's 4 n's, then there's 3 n's, and then finally there's 2. They can only have 2 in common. Everything else has leftovers, which is what we're going to put inside of our parentheses. But just so you can see what's going on here, once I'm dividing by everything that is going to be on the outside of my parentheses that's in my answer. What's left over will, if I have a negative sign out front, is going to affect all of these signs. They're all going to change to the opposite sign. So keep that in mind as well. So negative 27 divided by negative 3 is going to leave me with 9. N to the 5th divided by n to the 2nd is 5 minus 2, which is n cubed. And now I'm going to change this sign because 15 divided by negative 3 is negative 5. N to the 4th divided by n squared is n squared. And 2 negatives will make a positive. 27 divided by 3 is 9. N cubed divided by n squared is simply n. And then finally, 9 divided by negative 3 is going to be negative 3. And then n squared divided by itself is 1. So that's it for that one. And this is your final answer. I know most of you don't like to do this, but it pays to go back and double check it. And if you did that, you'll see that negative 3 times 9 is negative 27. And then n squared times n cubed, you add your exponents. So 2 plus 3 is going to be 5. So you should have that n to the 5th there. Then you're going to have your negative 3 times negative 5, which is positive 15, which you see. And then n squared times n squared is n to the 4th, which you see. Negative 3 times 9 is negative 27. And then n squared times n is n to the 3rd. And finally, your negative 3 times negative 3 is positive 9, and then n squared. So that is what you started off with. So you know that you did this correctly. All right, it's time to thumbs up and to subscribe. Have an awesome day.